There is a place on this planet that most people will never see, not because it is too far away, not because it requires special permission or extraordinary wealth or the favor of governments, but because it lies in a direction that human beings almost never think to look. Down, straight down, through the surface of the ocean, through the warm, familiar blue of the sunlit water, through the shifting green of the twilight below, through the absolute darkness of the midnight zone, all the way down to a place where the pressure of the water above would crush an unprotected human body instantly, where the temperature hovers just above freezing, where no sunlight has ever reached, where life extraordinary, alien, patient life has been going about its business for hundreds of millions of years, completely undisturbed by anything happening on the surface of the planet above. Tonight, we are going there, not in a submersible, not with cameras or instruments or the mechanical assistance of remotely operated vehicles, just your mind, your breath, the quiet of wherever you are right now. We are going to descend, slowly, zone by zone, through every layer of the ocean, from the warm surface to the cold abyss, meeting the creatures that live in each world along the way. So settle in, let your body become heavy. Let the world above the surface, the noise and the light and the movement and the endless demands of a human life, let it recede. We are going down now. The water is warm at first, and it will grow cold and dark and extraordinarily beautiful. Prologue. The world beneath. The ocean covers 71% of this planet. Most people know this fact. Most people have heard it stated in one form or another since childhood, but knowing it and feeling it are different things. 71%. More than 2/3 of the surface of the earth is covered by water, and most of that water is deep, extraordinarily deep. The average depth of the ocean is 3,600 meters, nearly 4 kilometers of water, pressing down with a weight and a force that is almost impossible to intuitively grasp. The deepest point, Challenger Deep in the Mariana Trench, sits at nearly 11 kilometers below the surface. 11 kilometers. If you placed Mount Everest at the bottom of Challenger Deep, its summit would still be more than 2 kilometers beneath the surface. And this vast, dark, cold, pressurized world is not empty. It is full of life. More life, by volume, than any other environment on Earth. Life that has never needed sunlight. Life that has evolved solutions to pressure and cold and darkness so elegant, so efficient, so completely unlike anything we have developed through our own engineering that marine biologists still struggle to fully describe what they are looking at when the cameras of remotely operated vehicles illuminate it for the first time. We have explored less than 20% of the ocean floor. Everything we know, all of it comes from that 20%. The other 80% is, in the most literal sense, unknown. Tonight, we begin the descent. Chapter 1. The Sunlight Zone. The epipelagic, 0 to 200 meters. The first 200 meters of the ocean are the ones we know. This is the sunlit zone, the epipelagic, the layer of the ocean that receives enough sunlight to support photosynthesis, to allow plants and plant-like organisms to convert light into energy, forming the base of the food web that supports almost everything above it. This is the ocean of coral reefs and sea turtles, of dolphins leaping in the bow waves of ships, of the great whale migrations that cross entire ocean basins each year. It is the ocean of the surface, and it is, in many ways, the least mysterious part of what we are exploring tonight. Not because it is simple. The ecology of the sunlit zone is extraordinarily complex, a web of predation and competition and symbiosis and seasonal change that marine scientists have been trying to fully understand for more than a century without success. But because we can see it, light reaches here. Our cameras, our eyes, our instruments work here in ways that they struggle to work below. We know this world, at least partially. What lives here? Everything that depends on sunlight, directly or indirectly. The phytoplankton, microscopic, single-celled organisms, drifting in their billions through the sunlit surface waters, converting carbon dioxide and sunlight into organic matter through photosynthesis. They produce approximately half of all the oxygen in Earth's atmosphere. Half. Every second breath you take was made possible by organisms smaller than the width of a human hair, drifting in the sunlit surface of the ocean. The zooplankton feed on the phytoplankton. Small fish feed on the zooplankton. Larger fish feed on the smaller fish. Dolphins and tuna and seabirds and whales feed on everything below them. The food web of the sunlit zone is the engine that drives the entire ocean. And it is powered, ultimately, by a star 93 million miles away. The sun, whose light reaches the surface of the ocean, penetrates the first 200 meters, supports billions of tons of microscopic life, and then at the boundary of the sunlit zone fades. Below 200 meters, there is not enough light for photosynthesis. Below 200 meters, the rules change. Chapter 2. The Twilight Zone. The mesopelagic 200 to 1,000 meters. Below 200 meters, the light begins to fail, not all at once. The transition is gradual, a slow deepening blue that takes the warmth out of the color first, then the brightness, then, eventually, almost everything. This is the Twilight Zone, the mesopelagic, a world of perpetual blue-gray gloom where sunlight filters down in faint, scattered columns that grow dimmer with every meter of descent. Enough to see by, barely. Not enough to live by if you depend on photosynthesis. The creatures that live here have solved the problem of this half-light in ways that are remarkable. Many of them are transparent. Not partially transparent, not translucent, but entirely, completely, invisibly transparent bodies of clear gelatinous tissue that scatter and refract the dim light passing through them in ways that make them effectively invisible to predators looking upward from below or downward from above. The jellyfish of the mesopelagic zone are among the most alien organisms on Earth. Ctenophores comb jellies drift through the twilight water like living lights. Their bodies are lined with rows of cilia, tiny, hair-like structures that beat in coordinated waves, propelling them slowly through the water. The beating of these cilia diffracts the ambient light, producing a shifting, iridescent shimmer that runs in waves along their bodies. They are not bioluminescent in the conventional sense. They are not producing light. They are refracting it, turning the dim blue light of the Twilight Zone into a private light show that serves, we believe, some purpose of communication or display that we do not yet fully understand. They have no brain, no heart, no blood, no bones. They are among the simplest animals on Earth in terms of biological complexity, and they are among the most beautiful things in the ocean. Chapter 3. Bioluminescence. The living light. Here, in the Twilight Zone, something else begins. Something that will become more and more prevalent as we descend deeper. Something that turns the darkness of the deep ocean into something unexpected. Light, not sunlight, not reflected light. Living light. Bioluminescence, the production of light by living organisms through chemical reactions, is not rare in the deep ocean. It is ubiquitous. Scientists estimate that approximately 76% of all deep-sea creatures produce some form of bioluminescence. More than 3/4 of all life in the ocean below the sunlit zone carries, in its body, the ability to make its own light. The chemistry is elegant. A molecule called luciferin reacts with oxygen in the presence of an enzyme called luciferase. The reaction releases energy not as heat, as most chemical reactions do, but as light, cold light, efficient light, light produced with almost no wasted energy. The purposes are as varied as the creatures that produce it. Counter-illumination, producing a faint glow on the belly that matches the dim light filtering down from above, making the creature invisible to predators looking upward. Lures, the famous dangling lights of the anglerfish, swaying gently in the darkness like a fishing lure, mimicking the bioluminescent signals of smaller organisms, drawing curious prey to within striking distance. Defense, the sudden, startling burst of brilliant light from a threatened creature, confusing a predator long enough to allow escape. or the release of bioluminescent fluid into the water, a glowing cloud that marks the predator, making it visible to other predators, turning the tables in an instant. Communication flashes and patterns used between members of the same species. In the darkness, where chemical signals diffuse too slowly and sound travels in ways that are difficult to control. If you could somehow float in the water of the Twilight Zone and turn off your own lights entirely, you would not be in darkness. You would be surrounded in every direction by the slow, cold, living light of 10,000 creatures going about their ancient business. A sky made of organisms. A darkness full of stars. Chapter 4. The Midnight Zone. The bathypelagic, 1,000 to 4,000 meters. Below 1,000 meters, the last traces of sunlight disappear entirely. There is no dawn here, no dusk, no seasonal variation in light, no day and no night in any sense that the surface world would recognize. There is only darkness. Complete, absolute, the kind of darkness that has no parallel in any human experience on land. Welcome to the Midnight Zone. The bathypelagic. The pressure here is 100 atmospheres at 1,000 meters, 100 times the pressure at the surface. At 4,000 meters, the bottom of the Midnight Zone, it reaches 400 atmospheres. 400 times the pressure of the air you are breathing right now. The temperature is between 2 and 4 degrees Celsius. Not freezing, the salt content of seawater lowers its freezing point, but cold, in a way that is absolute and permanent. The cold of a world that has never been warm, that cannot remember warmth, that has no concept of warmth. And in this cold, dark, pressurized world life, the creatures of the Midnight Zone are among the most extraordinary animals on Earth. Many of them have abandoned eyes entirely. In a world of total darkness, eyes are expensive. They require energy to maintain. They are vulnerable to damage, and they serve no purpose if there is nothing to see. Instead, they have developed other senses. Lateral lines, sensory organs that detect pressure waves and vibrations in the water with extraordinary sensitivity, allow them to perceive the movement of other organisms through the water without seeing them. Chemoreceptors, chemical sensors, detect the molecular traces left by passing organisms in the water, building a picture of the recent history of everything that has passed through the surrounding area. In the Midnight Zone, the world is perceived not through light but through touch and chemistry, not seen, but felt. Chapter 5. The Creatures of Darkness. In the Midnight Zone, evolution has produced solutions to the problem of existence that have no parallel anywhere else on Earth. The anglerfish. Perhaps the most famous creature of the deep ocean, its image so striking, so immediately recognizable, that it has become the popular symbol of the deep sea itself. The female anglerfish carries, projecting from her forehead, a modified spine, the Elysium, tipped with a glowing lure called the Esca. The light it produces is not generated by the fish herself, but by colonies of bioluminescent bacteria living within the Esca in a symbiotic relationship. The fish provides the bacteria with shelter and nutrients. The bacteria provide the fish with light. The light hangs in the darkness like a lantern, and the prey come to it, drawn by the light, drawn by the movement of the Esca, which the fish can manipulate, swinging it gently, mimicking the movement of smaller bioluminescent organisms. They come close, and then the jaws close. The anglerfish's jaws are capable of opening wide enough to swallow prey up to twice the size of the fish itself. In a world where food is scarce and encounters are unpredictable, the ability to consume anything that comes within range, regardless of size, is an extraordinary advantage. The fang-toothed fish, one of the most unsettling-looking creatures in the ocean. Relative to its body size, the fangtooth has the largest teeth of any fish in the ocean. They are so large that the fish cannot close its mouth completely. The lower fangs fit into specialized pockets alongside the brain when the jaw is at rest. In photographs, it looks like a nightmare. In the ocean, it is approximately 4 centimeters long, a creature that inspires disproportionate fear in an animal smaller than your thumb. The viperfish, its fang-like teeth curving back along its body in an arrangement that looks more like a trap than a mouth. the dragonfish producing a red bioluminescent light that most deep-sea creatures cannot see, using it to illuminate prey in the darkness the way a hunter might use a torch invisible to everything except the hunter. The gulper eel, a long, sinuous creature with a mouth that can open to an extraordinary size, the jaw disconnecting and swinging wide, engulfing prey in a single movement. Each one a solution. Each one shaped by millions of years of evolution in a world where food is rare and competition is intense, and every adaptation that improves survival, even marginally, persists. Chapter 6. The Abyssal Plain. The abyssopelagic 4,000 to 6,000 meters. Below 4,000 meters, the midnight zone gives way to the abyss. The abyssopelagic. The pressure at 4,000 meters is 400 atmospheres. At 6,000 meters, the bottom of the abyssal zone, it exceeds 600. The temperature is just above freezing, 1 or 2 degrees Celsius. Permanent, unchanging across seasons, across centuries, across millennia. The abyssal plain, the flat, sediment-covered seafloor that makes up the largest single habitat on Earth, stretches across the deep ocean floor in all directions. Covered in a layer of fine sediment that may be meters deep, the accumulated remains of billions of organisms that have drifted down from the surface over millions of years. Scientists call this material marine snow. It is, in its quiet way, one of the most important processes on the planet. The slow, continuous fall of organic material from the surface world to the deep carbon nutrients, the skeletal remains of plankton and fish and everything that has died in the water above, sinking through the water column over days and weeks, eventually settling on the sea floor. It is the deep ocean's food supply, and the creatures of the abyssal plain have evolved to exploit it with extraordinary efficiency. Sea cucumbers, soft-bodied, slug-like creatures, move slowly across the sediment, ingesting the marine snow-rich mud and extracting the organic material it contains, processing enormous quantities of sediment through their bodies. They are not glamorous animals. They do not have the striking adaptations of the anglerfish or the viperfish, but they are, in terms of biomass, among the most abundant large animals on the abyssal plain. In some regions, they cover the seafloor so completely that the cameras of remotely operated vehicles can barely find an unoccupied patch of sediment between them. The humble, patient, essential sea cucumber, processing the marine snow, cycling the nutrients, keeping the deep ocean alive. Brittle stars, relatives of starfish, extend their long, sinuous arms through the sediment, filtering organic particles from the water or picking them directly from the mud. Giant isopods, crustaceans related distantly to the pillbugs you might find under a rock in a garden, scavenge the remains of larger animals that sink to the seafloor. They can reach lengths of 45 centimeters. They can go without food for years, their slow metabolism allowing them to survive the long gaps between meals in this food-scarce environment. Patient, ancient, waiting. In a world where food arrives unpredictably, patience is the supreme adaptation. Chapter 7. The Hydrothermal Vents. In 1977, a research submersible descended to the seafloor near the Galapagos Islands. The scientists aboard were conducting routine geological surveys. What they found changed biology forever. On the floor of the ocean, where two tectonic plates were slowly pulling apart, superheated water was venting from the seafloor water that had percolated down through cracks in the ocean crust, been heated by the magma beneath, and returned to the ocean carrying dissolved minerals at concentrations that should, by every understanding of the time, have made life impossible. And around these vents, life, not sparse, struggling life clinging to a hostile substrate, lush, abundant, extraordinary. Giant tube worms, Riftia pachyptila, up to 2 meters long, their bright red plumes swaying in the superheated current like flowers in a wind the ocean floor had never previously known. Creatures with no digestive system at all, sustained entirely by symbiotic bacteria living within their tissues, converting the chemical energy of hydrogen sulfide into organic compounds, not photosynthesis. not sunlight, not any of the processes that life on the surface depends on. Chemosynthesis, life powered by chemistry rather than light. For the first time in the history of science, life had been found that did not depend directly or indirectly on the sun. The implications took years to fully absorb. If life could thrive here in complete darkness, at crushing pressure, in water laced with hydrogen sulfide and heavy metals, then the conditions we had always considered necessary for life were not necessary at all. They were simply the conditions that life had found on the surface of one particular planet. Other conditions were possible. Other chemistries could work. And if other chemistries could work here, on the floor of the deep ocean, perhaps they could work elsewhere. On the icy moons of Jupiter and Saturn, where subsurface oceans of liquid water might harbor their own hydrothermal vents, their own chemosynthetic ecosystems, their own extraordinary and completely independent forms of life. The discovery of the hydrothermal vents did not just change our understanding of the deep ocean. It changed our understanding of where life is possible in the universe. Chapter 8. The Hadal Zone. The Mariana Trench, 6,000 to 11,000 meters. Below 6,000 meters below the Abyssal Zone, beyond what most people imagine when they think of the deep ocean, lies the Hadal Zone, named for Hades, the underworld. The deepest places on Earth, the ocean trenches narrow, elongated depressions in the seafloor formed where one tectonic plate slides beneath another, plunge to depths that seem almost geological in their extremity. The Mariana Trench, in the western Pacific, contains the deepest known point on Earth, Challenger Deep, at nearly 11 kilometers below the surface. 11 kilometers. The pressure at Challenger Deep is approximately 1,096 atmospheres, more than 1,000 times the pressure at the surface. The first human beings to reach Challenger Deep descended in 1960, Jacques Piccard and Don Walsh, in a bathyscaphe called the Trieste. The descent took nearly 5 hours. They spent 20 minutes at the bottom before ascending. When they arrived, they found a flatfish, lying calmly on the sediment, moving slowly, in the deepest place on Earth, in conditions that should, by every understanding available in 1960, have been completely incompatible with complex animal life. A fish, going about its business. The Hadal Zone has its own communities of organisms adapted to the crushing pressure, the perpetual cold, the extreme scarcity of food. Amphipods, small crustaceans related to shrimp, are among the most abundant hadal animals, scavenging organic material that sinks from above. When scientists lower baited traps to hadal depths, the amphipods arrive in enormous numbers, sometimes thousands of them around a single bait source. In the deepest, most extreme environment on Earth, life does not merely survive. It congregates, it competes, it thrives. Chapter 9. What the Abyss tells us. We have descended far tonight, from the sunlit surface, through the Twilight Zone, through the Midnight Zone, across the Abyssal Plain, past the Hydrothermal Vents, all the way to the deepest place on Earth. And what have we found? Life. Everywhere. At every depth. Under every pressure. In every temperature. In every chemical environment that the ocean has presented, life finds a way. Not metaphorically, not as a hopeful sentiment, as a biological fact, demonstrated repeatedly, in environment after environment, depth after depth, for hundreds of millions of years. Life is not fragile. It is tenacious, inventive, relentless. It colonizes every available space. It evolves solutions to every challenge. It transforms impossible environments into home. The deep ocean reminds us of this. Every time we send a camera down to a new depth, every time we illuminate a section of seafloor that has never been seen before, every time we find organisms thriving in conditions we would have said, not long ago, were incompatible with life, something is there, going about its business, patient, adapted, ancient. The deep ocean also reminds us of how much we do not know. Less than 20% of the ocean floor has been mapped with high resolution. Every expedition to a previously unexplored region returns with species new to science. Not one or two, dozens, sometimes hundreds. We are still at the beginning of understanding this world. The largest habitat on Earth, the oldest ecosystem on Earth, the most biologically diverse environment on Earth, still mostly unexplored, still mostly unknown, still waiting in the dark and the cold for us to find the time and the technology and the will to look more carefully at what is there. Chapter 10. The Ocean of Sound. We think of the deep ocean as silent. It is one of the most persistent misconceptions about the abyss. The darkness we expect, the cold we expect, the pressure, the emptiness, the vast distances between one living thing and the next. But silence. The deep ocean is not silent. It never has been. Sound travels through water differently than it travels through air. Faster. Nearly 5 times faster, approximately 1,500 meters per second, compared to 340 meters per second in air. And further, much further, in the deep ocean, there is a layer of water called the SOFAR channel, the sound fixing and ranging channel, where the particular combination of temperature and pressure creates a kind of acoustic waveguide. Sound produced within this channel does not disperse in 3 dimensions the way sound in open air does. Instead, it is refracted back into the channel, trapped, guided along it. Sound produced in the SOFAR channel can travel for thousands of kilometers before it fades below detectable levels. Thousands. This is not speculation. It has been measured. Sound explosions produced in the waters off Australia have been detected by hydrophones in Bermuda, on the other side of the world. The deep ocean is, in the most literal sense, a planet-sized acoustic environment. And it is full of sound. The sound of the geological world, the deep, low rumble of tectonic plates moving against each other, of earthquakes occurring thousands of kilometers away, of volcanoes building themselves upward from the seafloor, in the slow, powerful grammar of the earth itself. The sound of the biological world, the clicks and calls and songs of whales traveling through the SOFAR channel, reaching animals hundreds or thousands of kilometers away. The snapping of shrimp, which in aggregate produces one of the loudest sustained sounds in the ocean. The low-frequency hum of fish schools. And the sound of the human world, the low, persistent, omnipresent noise of the global shipping fleet, whose engines send their low-frequency vibrations through the water of every major ocean basin, 24 hours a day, every day. The ocean has been getting louder for a century. The noise of human shipping has increased the acoustic background level of the ocean by orders of magnitude. In some ocean basins, the effective communication range of large whales animals, whose low-frequency calls evolved to travel thousands of kilometers in a quiet ocean, has been reduced to a fraction of what it was before the industrial era. They are still calling, but in a noisier ocean. Their voices carry less far. This too is part of the story of the deep ocean. The abyss is not separate from the surface world. It is connected to it, through the marine snow that carries the products of surface life to the sea floor, through the deep circulation currents that carry cold bottom water to the surface and warm surface water to the deep, through the sound that travels in both directions, carrying information, carrying meaning, carrying the accumulated acoustic history of everything that has ever made a sound in the ocean above. The abyss is not isolated. It is the deepest part of a connected system, a system that includes everything from the phytoplankton blooms at the sunlit surface to the chemosynthetic bacteria at the hydrothermal vents, a system that includes us, whether we choose to pay attention or not. Chapter 11. The midnight creatures we almost missed. There is a creature in the deep ocean that was not formally described by science until 2021. Not because it is small, not because it is rare, because it lives in a place we had barely looked. The big fin squid Magnapina was first captured on video by remotely operated vehicles in the 1990s. Long, sinuous, with arms and tentacles that extend outward and then hang downward at right angles, giving it a shape unlike any other cephalopod. It drifted through the midnight zone on footage that puzzled scientists for years. It took until 2021 to obtain a specimen detailed enough to formally describe the species. A creature that may be among the most widespread large cephalopods in the deep ocean, present in every major ocean basin, filmed repeatedly over 3 decades, and still, in 2021, new to science. This is the state of our knowledge of the deep ocean. The telescope octopus Amphitrachus pelagicus is almost entirely transparent. Its eyes, on stalks, point upward looking for the silhouettes of prey against the faint light from above. Its body, its organs, its entire internal structure, visible through its clear, gelatinous skin. It is one of the few known octopuses that spends its entire life in open water, never touching the seafloor. Drifting, hunting, transparent. In the midnight zone, the siphonophore not a single organism, but a colony. Hundreds or thousands of individual organisms called zooids, each one specialized for a different function: propulsion, feeding, reproduction, defense, working together in a coordination so complete that the colony functions as a single animal. Some siphonophores reach lengths of 40 meters, longer than a blue whale, the longest animals on Earth, living in the midnight zone, hunting in coordinated teams, using bioluminescent lures to attract prey into the body of the colony. Creatures that blur the boundary between individual and collective in ways that challenge our most basic assumptions about what it means to be an animal. The deep ocean is full of them, creatures that challenge assumptions, creatures that existed long before we arrived to notice them, creatures that will continue to exist, evolving, adapting, thriving long after our current understanding of them has been revised and expanded and corrected by better science, better technology, deeper dives. The abyss does not need our understanding to function. It never has. It simply continues, as it has always continued, in the dark, patient, extraordinary. Chapter 12. The Deep and the Climate. The deep ocean is not separate from the climate of the surface world. It is, in fact, one of the most important regulators of it. The ocean absorbs approximately 90% of the excess heat generated by human greenhouse gas emissions. 90%. Without the ocean's capacity to absorb and store heat, the surface of the Earth would be warming at a rate several times faster than what we are currently experiencing. The deep ocean is buying us time. Whether we are using that time wisely is a different question. The mechanism is the thermohaline circulation, sometimes called the ocean conveyor belt, a global system of currents driven by differences in the temperature and salinity of water in different parts of the ocean. In the North Atlantic, surface water cooled by Arctic winds becomes dense and sinks, descending to the deep ocean and flowing southward along the seafloor. This sinking draws warm surface water northward from the tropics, moderating the climate of northern Europe and the eastern United States in ways that make those regions far more habitable than their latitudes would otherwise suggest. The deep water flows southward, slowly, taking hundreds of years to complete a circuit. Eventually, it upwells, rises back to the surface in the Southern Ocean and the Pacific, carrying with it the cold, nutrient-rich water that supports the great marine ecosystems of those regions. The whales follow these upwellings. The fish follow. The seabirds follow. The thermohaline circulation is not just a climate regulator. It is the engine of the biological ocean, and it is slowing. As the Arctic warms and the Greenland ice sheet melts, the freshwater input into the North Atlantic is increasing. Fresh water is less dense than salt water. It does not sink as readily. The driving mechanism of the thermohaline circulation, the sinking of cold, dense, salty water, is being disrupted. The implications are not fully understood. The models are still being refined, but the direction of the change is not in doubt. The deep ocean, which has been quietly regulating the climate of the surface world for millions of years, is changing. Not at the pace of evolution, at the pace of human activity. And the consequences for the deep ocean, for the surface ocean, for the climate systems that depend on the thermohaline circulation will unfold over decades and centuries. The abyss, it turns out, is not separate from us. We are not separate from it. We never were. Chapter 13. 100 Miles of Darkness. Let us go somewhere before we sleep. Somewhere we have not been yet tonight. Out into the open ocean. Not the coastal ocean. Not the ocean you can see from a beach. The true open ocean. The part that lies beyond the continental shelf, beyond the shallow water that surrounds the edges of the continents and extends outward in every direction for thousands of kilometers of water so deep that the bottom is simply not a relevant feature of the landscape. In the open ocean, there is no bottom. Not in any practical sense. There is only water. Above you, the surface. Below you, more water. Around you in every direction, more water still. No landmarks. No reference points, no sense of scale that your body knows how to process. Just ocean. Imagine floating here, suspended in the dark water of the deep open ocean, weightless, surrounded by a darkness so complete that the difference between your eyes being open or closed is imperceptible. The temperature is cold, a few degrees above freezing. The pressure is enormous, hundreds of atmospheres pressing inward from every direction. There is no sound you would recognize, no wind, no traffic, no voices, only the ocean, which is not silent. There is the distant low rumble of shipping somewhere far above, sending low-frequency sound through the water for hundreds of kilometers. There is the sound of the water itself, the deep, slow movement of currents that have been flowing for centuries. And then, something else, a sound so low you feel it more than hear it. A pulse. It comes from somewhere far away, perhaps 50 kilometers, perhaps further. A blue whale, calling. The sound moves through you and past you and continues outward in all directions, carrying its meaning, whatever meaning it carries through the dark water at 1,500 meters per second. It will reach the other side of the ocean basin eventually. You hang in the dark water. And then, from somewhere behind you, perhaps 100 kilometers away, the faintest suggestion of a response. Another call, a different frequency, a different whale, answering, or perhaps calling for its own reasons, toward its own destination. Two enormous minds moving through the dark water of the open ocean, each one carrying 50 million years of evolutionary history in its body. Each one navigating by senses we do not possess, toward destinations we cannot know, in a world we cannot inhabit, calling to each other, or calling into the dark. Either way, continuing, as they have always continued, through every ocean this planet has ever had, through every change this world has ever made. Patient, ancien, alive. Chapter 14. The Return of the Light. We have been in the dark for a long time tonight. In the cold, in the pressure, in the extraordinary, patient, ancient darkness of the deep ocean. And now, slowly, very slowly, let us begin to rise. Not all the way, not yet, just enough to find the light again. From the Abyssal Plain, rising through the midnight zone. The darkness unchanged at first. The pressure, incrementally, releasing. The temperature, almost imperceptibly, beginning to shift. And then far above the first suggestion of something different. Not color yet, not warmth, not light in any meaningful sense, but the absence of absolute darkness. A faint blue-gray quality to the water. The beginning of the difference between up and down. We are entering the Twilight Zone, the mesopelagic. And here, something remarkable happens. The creatures that live at this depth in this transition zone between the sunlit world above and the permanent dark below have evolved eyes unlike anything on the surface. The eyes of the barrel-eye fish Macropinna microstoma are perhaps the most extraordinary eyes in the ocean. They are tubular, cylindrical, pointing upward from inside a transparent, fluid-filled dome that sits above the fish's head. Those green, glowing structures visible through the dome, the ones that look, at first glance, like eyes, are not eyes. They are olfactory organs. The actual eyes are the upward-pointing tubes inside the dome, capable of rotating to look forward or upward, maximizing the amount of faint downwelling light they can detect. The barrel eye lives its life looking up, watching for the silhouettes of creatures swimming between it and the dim surface light above, waiting, patient as only a creature of the Twilight Zone can be patient. In a world where the difference between seeing and not seeing something is the difference between eating and not eating, between surviving and not surviving, every photon matters. The Twilight Zone creatures have made photon capture into an art form. Mirror-sided hatchetfish whose silvery flanks reflect the downwelling light, making them nearly invisible when viewed from the side. Lanternfish with precise arrays of bioluminescent photophores arranged along their bellies, calibrated to match the intensity and color of the faint light filtering down from above, producing what scientists call counter-illumination, a living invisibility cloak made of light. Creatures that have spent millions of years learning how to disappear in a world made of shadows. And as we rise through this zone, feeling the light return, feeling the temperature shift, feeling the first faint warmth of a sun still far above, the dark lets go of us. Slowly, gently, the way night lets go of a winter morning. Not all at once, but irreversibly. Chapter 15. The Ocean's Memory. The deep ocean floor is a record. Not a record in the way we usually mean not written language, not deliberate inscription, but a record nonetheless. The finest, most patient, most complete record of Earth's history that exists anywhere on this planet. The fine particles that drift down from the surface world, the microscopic shells of foraminifera, the silica frustules of diatoms, the dust carried out to sea by wind and rain, the tiny crystals of material from volcanic eruptions settle slowly onto the seafloor and accumulate, layer by layer, millimeter by millimeter, century by century. A core sample drilled from the sediment of the deep ocean contains, in its layers, a detailed record of the history of the ocean and the climate above it. The ratio of certain isotopes in the calcium carbonate shells of ancient foraminifera tells us the temperature of the water when those creatures were alive. The species present in a given layer tell us about the chemistry and the currents and the conditions of that period. The presence of volcanic ash layers, thin, distinctive bands of glass shards mark specific eruptions, allowing scientists to date the sediment above and below with extraordinary precision. The layer of iridium-enriched clay that appears in deep-sea sediment cores from every ocean basin on Earth. At the same geological moment, that thin, dark line that marks the Cretaceous-Paleogene boundary, 66 million years ago, is the chemical signature of the asteroid that ended the age of the non-avian dinosaurs, preserved in the sediment of the deep ocean. Everywhere, a scar in the record of the Earth, in the sediment of the deep ocean, we can read the history of the climate going back tens of millions of years, the ice ages, and the warm periods between them, the great extinction events, the slow drift of the continents, and the changes in ocean circulation that followed. The deep ocean floor has been accumulating this record since before the dinosaurs existed, and it lies there now, undisturbed, in the cold and the dark, patient, as only stone can be patient, carrying its history quietly, waiting for whoever comes next with the instruments to read it. Scientists who study these sediment cores speak of the experience with a particular reverence. Each centimeter of core they hold represents thousands of years. The core itself, perhaps a meter long, perhaps 10, contains millions of years of unbroken time. They hold, in their gloved hands, the memory of a world that had no one in it to remember it. Until now. Chapter 16. The creatures that time forgot. Not all change happens quickly. In the deep ocean, where conditions shift slowly, where the temperature has been cold for millions of years, the pressure constant, the darkness absolute, some creatures have changed very little. Not because evolution has stopped, but because the environment has not required change. Because what worked 50 million years ago still works today. The Nautilus drifting through the deep water of the Pacific, on the edges of coral reefs and open ocean, is recognizably similar to nautiloids that swam in the oceans of the Paleozoic era over 400 million years ago. Its coiled shell, its simple, lensless eyes, its jet propulsion, drawing water into the mantle cavity and expelling it to move backward through the water. These things have worked for 400 million years. They still work. The Nautilus does not know that the world above it has changed beyond recognition since the Cambrian, does not know that the continents have moved, that the atmosphere has transformed, that species have risen and fallen in their hundreds of millions above the waters where it drifts. It simply is, doing what it has always done. In the dark water, the horseshoe crab, not a true crab, more closely related to spiders and scorpions, has been walking on the seafloor in essentially its current form for 450 million years. It predates the dinosaurs by nearly 400 million years. It has survived every mass extinction the Earth has experienced since the Cambrian, the Ordovician extinction, the Devonian extinction, the Great Permian-Triassic extinction that killed 96% of all marine species, the asteroid that ended the Cretaceous. Through all of it, the horseshoe crab continued, walking slowly across the seafloor, doing what horseshoe crabs do: patient, unchanged, ancient, beyond any adjective we have for ancient. There is something quietly extraordinary about these creatures. Not the drama of the great predators, not the strangeness of the deep-sea abominations of bioluminescent lures and hinged jaws and transparent bodies. Chapter 17. Sleep at the bottom of the world. It is very late now. The world outside is quiet. Wherever you are, in whatever room, in whatever city or town or place that is yours, the particular silence of late night has settled around you, and somewhere, far below the nearest ocean surface, the deep water continues its ancient business. Cold, dark, patient, let your body feel the weight of itself, not as a burden, as a comfort, the solid, reliable, trustworthy weight of a body that has carried you through everything today asked of it. Your shoulders, let them settle. Your jaw, let it release. The space between your eyes, that place where the effort of the day accumulates, where the small tensions of attention and concentration collect without being noticed, let it soften. Let it go. Breathe slowly. In and out. In and out. The rhythm of it, like the rhythm of the tides, like the slow, enormous breathing of an ocean that has been breathing for 4 billion years and will continue long after any concern you carry tonight has dissolved into whatever concerns become when we stop holding them. Think, if you wish, of the barrel-eye fish in the Twilight Zone, those extraordinary upward-pointing eyes, looking for light in a world of shadow, patient in the dim water, waiting. Think of the sediment falling. Always, somewhere in the ocean, particles of organic material drifting downward through still water, slowly, without urgency, finding, eventually, the floor, settling, the way thoughts settle when you stop pushing them, the way the day settles when you let it. Think of the horseshoe crab, walking slowly across the seafloor in the dark, doing what it has done for 450 million years. One step, then another, patient as only something 450 million years old can be patient. Somewhere in the deep ocean right now, the hydrothermal vent is warming the cold water. The tube worms are swaying. The Dumbo octopus is moving through the dark like a thought too gentle to hold on to. The siphonophore is drifting 40 meters of colonial life, bioluminescent, ancient, extraordinary through water that has not seen sunlight in millions of years. The blue whale is calling, its sound traveling through the Sofar Channel, crossing ocean basins, reaching eventually another whale, or perhaps not, perhaps traveling all the way to the far shore of the ocean and dissipating there, having been heard by no one. A call into the dark, patient, continuous. The ocean does not need an answer to keep calling. It simply does what it does, as it has always done, and you can rest in that, in the knowledge that the world does not require your attention tonight, that it will continue its ancient work without you, that the deep and the cold and the dark will go on patient and vast and full of life we have not yet found through all the hours of this night and every night that follows. Let your breathing slow to its own pace. Let the images from tonight's journey settle gently, like marine snow into wherever such things go when the mind grows quiet. Final sleep sequence. It is time to ascend now. Slowly, the way a diver rises through the water column, pausing at each depth, letting the pressure equalize, not rushing, trusting the process. From the huddled trenches, rising through the Abyssal Plain, past the hydrothermal vents, their superheated water still pouring into the cold darkness, still feeding their extraordinary communities of life. Through the midnight zone, where the anglerfish hangs its light in the darkness, and the fangtooth waits with infinite patience. Through the Twilight Zone, where the comb jellies shimmer and the marine snow drifts downward past you on its long journey to the bottom. And then the first trace of light, blue, faint, coming from above, growing brighter with every meter. The surface, the warm, familiar, sunlit surface. Let your body be still now. Feel the weight of it, the comfortable, reliable weight of a body that has traveled far tonight, through darkness and pressure and cold, through some of the most extraordinary places on this planet. Let your shoulders settle. Let your jaw release. Let your breathing slow. In and out. Somewhere, right now, the deep ocean continues. The sea cucumbers move slowly across the abyssal plain, processing the marine snow. The anglerfish hangs its light in the midnight zone, waiting. The tube worms sway in the current of the hydrothermal vent, sustained by chemistry rather than sunlight. The amphipods of the Mariana Trench go about their ancient business in the deepest place on Earth. None of them know you exist. None of them need you to witness them to continue being extraordinary. But you know about them now. You have been there, in your mind, in the quiet of this night, and that knowing, that sense of a world so much larger and stranger and more alive than the one we usually remember to notice, is something you carry with you, back to the surface, back to this room, back to this breath. The abyss will be there when you wake, patient, dark, alive, in ways we are only beginning to understand. But for now, you are here, warm, safe, breathing. Sleep.